When you decide how many digits you want to use to represent a value, you are deciding how many significant figures to use. Significant figures include the numbers on either side of the decimal point that seem reasonably certain. This is a little weird, but they're just some rules you need to learn.
For instance, the number 1.075 has 4 sig figs, and 2.00127 has 6 sig figs. The number 0.0075 has only 2 sig figs, since the zeros in the number only serve to locate the decimal point. Same with 0.0000362. Those zeros don't have value. They just tell you where the decimal point is. So, 0.0000362 only has 3 significant figures.
When you make calculations, you have to decide how many significant figures to use in your answer. If the answer has more figures than are significant, you can round it off. Here are some general rules for sig figs.
For addition and subtraction problems, give the result in as many decimal places as the number in the problem with the fewest decimal places. Remember, decimal places are only the numbers after the decimal point. For example, 10.712 plus 3.61 equals 14.322. But since the number 3.61 in the problem only has 2 decimal places, we can only use 2 decimal places in our answer. The final number just isn't significant.
Multiplication and division problems are handled a little differently. You round off the result so it has the same number of significant figures as the number in the problem with the fewest significant figures. Get the difference? With addition and subtraction, we rounded our answer off to match the number in the problem with the fewest decimal places after the decimal point. Multiplication and division answers are rounded off to match the number in the problem with the fewest significant figures, which can be on either side of the decimal point. For example, 2.32 times 77.96 equals 180.8672. But since 2.32 has only 3 significant figures, our answer can only have 3 significant figures. So we round the answer to 181. Got that? Good. Handle division problems the same way.
And since we're into reducing the numbers of numbers, let's not forget scientific notation. Scientific notation cuts back on the decisions you have to make about significant figures because it reduces the number of zeros in big numbers. You may know scientific notation already, but here's a review.
Scientific notation is a way of writing really big or really small numbers. It uses powers of 10 to express the number. For example, instead of writing 32,100,000,000, you'd write 3.21 times 10 to the 10th power, or 3.21 times 10 billion. It will appear on your calculator as 3.21E10 or 3.2110. A small number like 84 billionths would be written down as 8.4 times 10 to the minus 8th. A calculator would show either 8.4e minus 8 or 8.4 minus 8.